All right, guys, we're back, and one of the things that we have to decide is to how much detail we actually go regarding every aspect of Swift. We obviously can't discuss everything, so the idea is that some basic things we go over, and then the more advanced topics you have to, if you're interested or when needed, you can actually find yourself. So we've talked in this module for about an hour so far about the different topics like properties and closures and optionals. There is one more item that we believe, and Jack strongly believes, that that's very important that we do need to discuss with some depths. But then after that, what we're going to do is provide essentially a very quick summary cheat sheet of what are some of the advanced topics that you should be aware of. And if anything is of interest, then we'll cover it maybe to a certain extent, but then we'll leave it up to you to find out more information by yourself. But before we get to that, we're going to talk about value types.
Yes. So we mentioned this a bit up to now in the course already. There is a difference. Up to now, we've talked about reference semantics within our properties and optionals. But there's also sort of value types. And these are just giving names to things you already know, okay, if you've done programming. So say you have an integer, and it's equal to 3, and then you assign it to b, and then you change b. Let's make them all variables. And you change b equals to 5. So what do you expect a to be? It would be 3, right? If in any language doing this with sort of an integer, it would be really weird if a also changed to 5. But it wouldn't be weird if it was a class. So what this is displaying here is sort of value semantics, which means what matters about this integer is its value. It doesn't matter like where it came from or like what its origin is, its history, its story. It's just its value, which is 3. And when you assign it, all you have to do is copy the value. And so a is a value of type 3. A value type with the value 3, and b is assigned to a. And when that happens, a is copied into b. And so when you assign b to something else, it doesn't change a at all. And this is a classic example of a value type, and something that you should be very familiar with because you would be very surprised if it behaved some other way. But again, let's bring back our number type. That simply holds a number. And you see where this is going. Like if I create and it's default to 0. All right, we're actually going to create an initializer.
And as Jack's writing this, essentially, if you're used to C, the point of this is pointers. So if you have a pointer that is equal to a different pointer, they're actually pointing to the same object. Then if you change one object, the other one, because it's pointing to this same object, that would also change.
Yes, so if there was sort of a pointer syntax, that would be easier to understand in Swift. The thing with Swift is there's no pointer, right? You're not sure, just by the assignment and sort of creation, you're not sure if it's a pointer or not. And as we'll see, like a number can be a number with 3. And we'll copy that for b, and make it equal to a. It's complaining about the label. And now if I set b.n is equal to 5, you expect a.n to also be 5. Oh, right, it's a number and b number. Right. So b number dot n changed, but a number dot n also changed, and that also makes sense. But as you can see here, the syntax here is not that much different, and the only thing causing this behavior is because this is a class. The way we're going to talk about this is a is a value, integers are value types, and numbers are reference types. So when you're assigning it, all you're doing is assigning a reference. Because for classes, you don't know how much data it holds. It can hold like huge amounts of data, and you wouldn't want to make copies of it. And that's just sort of a classical programming solution, is to assign its reference. And so for reference types, when you assign b to a, it's simply pointing to the same object. And then when you change b.n, you're changing the same exact thing as a.n. Okay, so why is this more important in Swift? It's because Swift brings out value types sort of more front and center compared to some other languages by providing structs. So a struct is very similar to a class, except that it's a value type. So we have this almost pretty much the same exact class. I'll make it like super exact by literally copying in the init function. And just by even better, let's just change this to a struct. Just by doing that, you'll see the behavior completely change. And this is because all of a sudden, struct is number is now a value type because you declared it as a struct. And and now it behaves sort of like integer. When you assign it, it copies the entire struct, including all its internal values. And now after we assigned it, it remains 3. So that's the main idea that we want to cover here is the difference between value types and struct types. And I guess we'll talk a little bit about their advantages. So why are value types valuable? It's because you don't have to worry about where they came from and don't have to worry about behavior like previously with a class. And it allows for more safer code when dealing with data. Values are references are passed around a lot, and many people can have sort of a reference to the same reference, to the same object. And when you modify it, it can have undesired consequences. Maybe you change someone else's value that they were depending on unintentionally. But when you're using a struct, you know that you have your own copy, and it's very safe to modify it.
Now, there may be cases you actually do want a class. You do want the fact that when you copy it, it's passed by reference. But essentially, the summary so far is that classes are copied by reference. Structs are, although in many ways the exact same as class, they're copied by value.
Yes.